Okay, so we're going to start our new. We've done this once before while I was learning Rust, but we're going to start a new data structures and algorithms series here on twitch.tv/metame with 4 E's, by the way. And if you're wondering how that happened, I just kept typing E's until they let me use it. Amazingly, of all the Substacks in the world, metame.substack.com was not taken. So that's kind of nice. That username is taken on most platforms. More than 10 years ago when I started using it everywhere. So that's unfortunate. It's good if you've picked. Okay, I'm getting distracted. No one is wondering. I was wondering. Yeah, no one's wondering. That's true. Now you sound like that guy who. Okay, I'm getting distracted again. I was trying to do like a nice intro and it didn't work. So this is just all gonna. We all know I don't edit YouTube videos, so this is all just gonna go in the YouTube video. Okay, so here we go. Data structures and algorithms in Rust. We're going to do some fun ones, and I'll probably do 2 playlists. I'll do one that includes both me writing the blog and me writing the code, and then one that's probably just me writing the code. That will probably be the 2 playlists that I'll create on YouTube for these things, so that people can easily follow along. In case the difference is going to be the blog is really me like putting it all together, thinking about different things, and hopefully the code part is just me actually implementing the algorithms, right? So that's the plan anyway. Yeah, it is chat's job and it is part of it. I just can't get too distracted, otherwise I literally won't do anything. Okay, so this looks good. What was I going to do? Oh yeah, that's what I was going to do. I was going to show you what we're actually going to work on in the series. And we have linear search, we have binary search, we have a linked list, doubly linked list. We'll probably do some more of these things as well. No, I mean, we will. And this will all be in Rust. Some of it requires unsafe. A lot of it doesn't. A lot of it doesn't require unsafe as long as we have good usable data structures underneath, like this raw vec here, which we'll implement at some point. I don't remember how to do all of these from the last time I did this. The last time I did this was like September, October of last year, which right now we're in April of current year, which means we're, 6 or 7 months ago. So some of this will be refresh, and some of it will be new, and the implementations probably won't be exactly the same. And I think that will just make everything fun. So we're starting with something simple, which is linear search and binary search. I'm going to just title this search algorithms. I think that's fine. Obviously, there are many different search algorithms. Maybe we'll say basic. Simple. We'll say basic. Basic search algorithms in Rust. Okay. Infinite Coder coming in with that raid. Thanks for the raid, Infinite. I saw you were streaming earlier. I didn't have time to join. I hope it was good. I think I typed your username. What's up, Merrick? How's it going? Oh, shit. I just did raid instead of shout out. No, cancel. It's so me. Shout out. I'm gonna raid Infinite Coder after he just raided me at the very beginning of my stream. Okay, there we go. I do that so often. It's remarkable. It's amazing that I even have it. It's amazing that I even know how to click start stream on OBS. Honestly, I don't even know how I figured that part out. Okay. It is funny because like I've thought about like multi-streaming just for fun and stuff like that. And I'm like, I would actually have to like think about how to do that. And then I'd have to go spend time figuring it out. And that it's just a little too much work. So sorry, YouTube. You just get the VODs, all right? If you want to watch live, you have to be on Twitch. That's how it goes. Let's see. So we'll just call this basic search algorithms. The real point is we have linear search. Oh, what? Linear and binary search. Okay. I keep forgetting that's a subtitle. Okay, so we're going to have linear search. I can't type. And we're going to have binary search. Okay. And I guess we need to put some sort of info. You almost got rated. You did some work and even had a chatter. You do multi-stream to YouTube? Oh, that's cool. With the multi-RTMP OBS plugin? Okay. I haven't looked at that. I'm going to open that in a tab on the side here. I'll think about it. Multi-RTMP OBS plugin. Did you just split their name? You might have. We'll see. We'll see. We'll make sure that's Mac compatible and everything. And my computer compatible. All right. So basic search algorithms, linear and binary search. We're going to start this series with the most basic of algorithms. You have a list. You have a sequential. We'll just say that. A sequential data structure of some sort. And you want to search through it. All right. This works. You have Henley-Milner type inference in your compiler, and now you're doing variables. Nice. No, that's really cool, man. I mean, implementing type inference and everything, that's a lot of fun. I haven't done it myself. I just mean, like, it's very cool. Linear search. Okay. Linear search. Chances are you are already using linear search. Otherwise, I don't know how you do anything in your code. The most basic form of this. The most common, we'll say common. The most common form of this is often done in a loop construct, like for. Like a for loop. Does that not work? Is that not Markdown? Did I just make this up? Because usually it just auto updates my Markdown for me. Maybe I just need to do. Is that like extended Markdown? Iterator.position or slice.found. Yeah, exactly. The most common form of this is done in a loop construct, like a for loop in most languages. Okay. So is there a preview? There is a preview. So let's do this. That is Markdown, isn't it? It's a boomer moment. Wow, look at this. Look at this mobile preview. Let's go. Really? It's taking this long? This is hurting. Okay, can we get to desktop? They're using an Intel Mac to make this. Why isn't this working? Does it use a Brave feature that I've disabled, or a feature that Brave has disabled? It must use a feature that Brave has disabled. There's no reason it should take this long. What the hell? Okay. I'm guessing it auto saves my drafts, right? Okay. Let's just disable shields on Substack and try that again. Okay. Substack? Is it my internet? Is that the problem? Like, I mean, I'm still streaming. I doubt it's my internet. I mean, my internet is hella slow right now. I'm only getting 130 down, which is really bad considering I have fiber. But not bad enough for this to happen. Does Substack just not work with Brave? Can it not find my post? Okay, let's just restart. metame.substack.com, publish posts. Let's look at drafts. Did I break Substack? Like, why is literally nothing working? This is pretty sus. Does the rest of the internet work? Just load the Twitter homepage. Okay, the internet does work. That's good. Glad the internet works. Substack, on the other hand, does not work. I guess we'll just kill the tab and go back into it. I'm pretty confused. All right. Well, I guess we found out that Substack does not know how to work. All right. Let's go back to putting shields up and see if everything loads. It'd be really funny if it did. I don't like how is this happening? Let's go to settings page. Can you load anything? I guess I killed my session or something. Yeah, maybe I'll just try logging out and logging back in. All right, let's do that. Let me go into a different tab and I'll log back into Substack, or log out and log in. It's, where the fuck do you log out in this thing? Can I log out? Are you going to let me? What the hell is wrong with Substack? Did they decide that I'm a bot and blocked my IP? Okay, so their homepage loads, but I can't get like anything else to load on their site. This is what I get for saying, okay, I'm just going to do something that I know is going to work. Because it doesn't work. All right. Let me just try and Chrome real quick, I guess. Just to see if it's a browser issue. Stupid Chrome. I didn't want to have to use Chrome. Substack.com. I mean, even here, it is being weird and insanely slow. Okay, Yeah. And we have an email. I'm sorry about all this, folks. This is really, really dumb. Okay, I'm signed in on Chrome. And yeah, okay. Chrome just loads everything. Shit. I think this really is a Brave problem. I can't imagine Brave literally breaks Substack. Like, how is that possible? Posts. Oh, don't have Dark Reader on Chrome. It's killing me. Drafts. And it saved everything I did so far. Weird. All right. I think I'm actually just going to restart Brave real quick. Do I want to do that? I'm considering it. Let's just try this one more time. See, like on Chrome, this notes section populates with a bunch of like weird community notes. Not that I asked for that, but it does. And like the menu actually works up here. Unbelievable. Okay, I guess we will just do it on Chrome, even though I don't want to. That's really weird and concerning. Okay. 1 second. Let me get back to my actual post and we'll add Chrome. There's always Safari. I could do Safari. I mean, it'll be fine since I'm just sharing the window. I try not to share anything that I actually use for work so that I just, like I try to only import things into OBS that I've actually that I don't use for work. Let me get Dark Reader and then we'll import this into OBS. Well, this series is going really well so far. Yeah, that's exactly how I do it, Purplish. Exactly how I do it. Okay. Well, it's nice to know that their weird black box thing happens on my computer no matter what. Okay, that means I'm going to have to install CTRE in Chrome too. It's so dumb. CTRE. Really? Control C, can click to, no, C. Yeah, it is what it's called. Click to remove element. I can't believe it made me type that out. I feel like this is not the one I use in Brave. No, it is. It's the same one. Okay. Just making sure. It didn't show me the right logo at first. Okay. So that's good. Click to remove element. doesn't remember by default. Black box is gone. We're so back. Okay, let me get this Chrome browser shared in OBS. We are going to copy this and paste it. And then we're going to change this to Chrome. Where are you, Chrome? There you are. Okay, and then put you in the right place. All right. That should work. What's up, Nightshade? We were just dealing with skill issues, but it wasn't mine. It was actually Brave browser's skill issues. All right, so let's see. We'll make this a little bit bigger for the folks at home. What, a code like that? Well, this is just writing the blog, but I don't know what you mean. I code over here. You know, this is my editor. I only code in Substack actually. Yeah. So for some reason, Substack super didn't work in Brave, which is annoying. All right. So this looks good, and the most common form of this is often done in a loop construct, like a for loop in most languages. Let's see. So I don't think I need to give an example of a for loop. I think in Rust, the built-in, let's see. Yeah, I think this is fine. In Rust, the linear search is accomplished. That's really bad delay. I think my computer is doing something stupid. Oh, you still see my editor. That makes sense. That is because I usually use Brave, which has this nice auto switch. But now I had to switch to Chrome. But yeah, thanks. I appreciate that. I know I'm signed out of Grammarly. I don't need to be signed into Grammarly. Okay. In Rust, linear search is accomplished with what? Oh, let's open up Rust docs in Chrome. I'm so mad right now. I'm so mad I have to do it this way. Effing Substack. Maybe I should just write this as a markdown post in Emacs and then copy it. Mobile was going sideways. You mean you were having issues with the Twitch mobile app? I don't believe that. In Rust, linear search. I didn't mean to do that. I don't know what I'm doing. All right, so there's iterator find. Which is shocked Pikachu. All right. So there is iterator find, and I don't think there's anything similar to that on, like, you actually have to use iterator find, don't you? Or I don't think Vec has a find, if I remember right. It does not. It's a beast of a PC, yeah. All right. Yeah. You have to do it through iterator. I mean, yeah, get on slice is different because that's get by index, which makes sense since for loops automatically. Oh, for your new computer, is that what you're talking about, Nightshade? Your new rig? Nice. That's awesome. Sort split, take swap. Yeah. Okay, cool. I just have to double check things. In Rust, linear search is accomplished through the find method of the iterator trait. Okay. Google's how much that is in kilograms. A lot. How much is that in kilograms? A lot. Roughly 120 kilograms. Wait, did I do that right? I think so. Okay. Was it in a crate? No crate. It didn't have Rust in it. Nice. Nice. Good one. In Rust, linear search is accomplished through the find method of the iterator trait. I guess we could link to the docs because that seems like a really kind thing to do. Why did it go all the way to the top? Because I pressed that? Sure. Of the iterator trait. Whoops, not what I meant to do. Why is this so blurry too? Why is it? It's so blurry even for me. And slow. What the hell? I'm really annoyed right now. I don't know if I can do this. Let's look at task manager. How much is this one stupid tab eating up? Of course, just for having Chrome open on my computer, we're eating just an insane amount. Oh God, LastPass is eating 72% of CPU, even though it's literally just sitting there. Killing me. Oh God. Okay. Yeah. Yeah, I don't know how that would... I just killed it. I don't know what it was doing. Wait, did you ping me, Nightshade? Is that what you're saying? No. I don't see a ping. I don't know what's going on today. Oh, you guys are talking about the packaging. Got it. In Rust, linear search is accomplished through the find method of the iterator trait. That should be good. Computers channel. Okay, I'll look later. Of the iterator trait. This method takes an implicit argument of self. This method, yeah. takes an implicit argument of and mute self and a predicate, which how do they define those? Technically all that and a predicate and a predicate. People can look at the docs if they really care what type of predicate it is. And if you don't know what a predicate is, I'm not going to explain it to you. I'm sorry. This method takes an implicit argument of mute self and a predicate. We can easily... Okay, so then we get into the implementation details. Okay, so that's what linear search is. I think this is fine. Through the find method of the iterator trait, this method takes an implicit argument of mute self and a predicate. While you can use a for loop and have an implicit call to dot to iter, or is it just dot iter? I forget what a for loop does. If it's an implicit or not. It's like Rust book. Yeah, there's both, but I'm trying to remember. Isn't there an implicit? If you just say for element in vec, do you have to call one of those, or does it do one of them implicitly? That's the thing I can't remember. For loop. We'll see. Okay. So this works. Sure. Okay. Rust for loops call iter method. Okay, implicitly calls dot into iter. That's what I thought. Implicitly calls into iter. Yeah. Okay. And I said to iter. Maybe that was your point, Prophet, is that I didn't even do the right method at all. I was thinking of into iter. It's funny. While you can use a for loop and have an implicit call to, and we can make that simpler. And implicitly, that's not what I meant to do. I was using a Vim motion there to try to delete the word in front, and that didn't work, by the way. And implicitly call into iter. Linear search is... I don't know if it's true that it's more idiomatic to use find on an iter than for. Obviously, they do different things. Because it's not like a for loop is just linear search. It's just a certain way for you to traverse through a sequential data structure. Linear search. Hey, Fox4JJ. I'll just say can also be accomplished through the find method of the iterator trait. This method takes an implicit argument of mute self and a predicate. Exactly. Yeah. It's like linear search. Exactly. Yeah. In Rust, while you can use a for loop and implicitly call into iter. Yeah, that's a good point, Prophet. I like that. While you can use a for loop and implicitly call into iter, linear search is accomplished through the find method of the iterator trait. Okay, we'll just leave it there. I was trying to NB for the well actually people there, but I decided this is actually more correct. This method takes an implicit argument of mute self and a predicate. A basic example of linear search. A basic implementation of linear search on an iterator is below. Okay. I guess I have to do another space to have this. I mean, what's wrong with you people? Implementation of linear search on an iterator. It would really suck if they didn't actually support Markdown completely in Substack and I was just doing all of this for no good reason. Basic implementation of linear search on an iterator is below. And this is a to-do for when I actually write the code. Okay. How do I get... No, stop this. I'm trying to do something specific. There. I want to be up here. Okay, good. If we wanted to implement a... you could say more generic. Sure. A generic version of linear search. If we wanted to implement a generic version of linear search on a slice, if we wanted to implement a generic version of linear search on a slice. The point is that like I have to give them the slice implementation because implementing binary search on an iterator doesn't really like, it doesn't quite work. Exactly. Well, I'm sure that was that boring AF? Like I don't know how you sit through classes about stuff like that, but maybe there were interesting aspects to it. But I'm glad that this is relevant to you. Planned, yeah. I was talking to your professor, Prophet, to make sure that like my stream content would actually line up with his lecture or her lecture schedule. So yeah, just so you know. Having a hard time. Yeah, exactly. Because you're the main character, Alice. If you didn't already know that, you're the main character. Okay. If we wanted to implement a generic version of linear search on a slice, it's not, it's like, I want to write this. It would look like the following. And it's like way too many words for something that is dumb. Slice.search, easy. Yeah. Nice. Wait, is there a slice.search? I forget. I'm so bad at remembering everything that exists. I mean, to be fair, the Rust standard library is so freaking large that I just can't remember what they call everything. You're killing me, Nightshade. You're talking about methods that don't even exist. Oh, it's Badger. I was blaming Nightshade for it. Okay. Okay, good. Good. Badger is an LLM confirmed. It's the green. Okay, you guys are very close in your shades of green on the usernames. These old eyes can't always tell the difference. If we wanted to implement a generic version of linear search on a slice, okay, how about this? Let's take out all the filler words. A generic version of linear search on a slice Okay, a basic implementation of linear search on an iterator. How about we take out is below? A generic version of linear search on a slice. Okay, let's go. Linear search is simple. But depending on the size of, on the number of elements, we'll say that. Number of elements being searched, it can be slow. Why? As the name implies, linear search takes linear time in the worst case, aka O of n. Time complexity. Thus, we may... Okay. Enter binary search. Okay. I'm not going to do any little cutesy transitions. As the name implies... Okay, why... Yeah, I know I'm signed out of Grammarly, but... So it's kind of rude that you give me a red squiggly and then you say I'm signed out. I guess it's because you don't need the comma. As the name implies, linear search takes linear time in the worst case, aka ON time complexity. Okay. Because we should be able to... No, that doesn't make any fucking sense. Enter binary search. pick in Discord. Nice. Badger's so random. Oh my gosh. I don't even know how you do those things. Anytime I see a picture, anytime I see a special character, I just copy and paste it. Nice. Enter binary search. Yeah, enter binary search. To beat linear time. When searching a sequential data structure, we can use binary search. The basic idea of binary search is that it splits the search space in half on every, we'll say at every step. At every step. The basic idea of binary search is that it splits the search space in half at every step. The drawback being that it only works on a sorted sec. Is it too confusing to say things like sequential data structure and sequence? Like, I mean, I assume the drawback being that it only works on a sorted sequence. Maybe I'll just say up here. Okay. We're going to start where you have a sequential data structure of some sort. How do you say that? Herefore known as known as a sequence. And you want to search through it. I think that's pretty good. ASCII box drawing. Is it heretofore? Heretofore. What a great English word. Heretofore. No, I can't write that. Okay. Can we is that just like a generally accepted definition of a sequence? Sequence definition CS. Nope. Sequence is the order of in which instructions. Okay. So we'll just call it. It's a general thing in CS, but it seems to mean something else. You have a sequential data structure of some sort. We'll just call this a sequence from here on out. So many words. You think it makes sense? All right. If Prophet thinks it makes sense, then a sequence oh no. What is the time complexity of binary search on a doubly linked list? Um, I mean, it's not good. I mean, the issue is the answer is 5. What's up, Toggle Bit? Yeah, 5 is definitely the answer. The answer is 5. That's great. Let's see. So if we have a doubly linked list and we are splitting it recursively, like it's really, really bad because you don't have pointers to the middle or anything like that. So I don't know what it is, but it's worse than O of n, right? It would have to be. Because you'd have to go through, split it, and then at each step, like it's worse than, of course, just like sequentially going through it. Yeah. Let me think. Because if you want to say, oh, split this list in half, I mean, if you're storing length, you could store length, right, on your doubly linked list, but that still doesn't, like, at least you know how many things you're going through, so that length also doesn't take O of n. It's really bad. So I would say it's at least like n squared. I mean, if we count the sort to, yeah, I don't know. I feel like it might even be n cubed if you would. It's actually linear. Okay, let me just see. Okay. Since you need to go n divided by 2 steps to reach the element in the middle, then n divided by 4 to reach the next one, followed by n divided by 8 and divided by 16, which converges to n. Okay. And this, of course, if we're not counting that length in some languages is an O of n operation on a linked list. We'll just pretend that's not a real thing. We'll pretend that we know how long it is and that, like, we're just splitting it in half, right? You can cache the length, yeah. But either way, even if, no matter what, if you know the length, you're going to have to go n divided by 2. Oh, that's interesting. Because then you know where you're going to start. Okay. Yeah. It's still a pretty bad algorithm. No, that is interesting. And one of those times where you're like, does time complexity really matter anymore? But no, I mean, it does, right? Right, it matters. Yeah, that's silly. Yeah, if you don't count the sort, obviously, which, I mean, in general, in binary search, we don't count the sort. We just say it has to be sorted before it goes in. It matters when it matters. Yeah. Wise words, Nightshade. Wise words. Okay, let me do a quick message check and we'll keep going. All right. To beat linear time when searching a sequential data structure, we can use binary search. The basic idea of binary search is that it splits the search space in half at every step. The drawback being that it only works on a sorted sequence. Okay, I think I said sequential data structure again. Unless you can use the linear search to accomplish the find method of this method today. Okay, I didn't. Okay, it's fine. Okay, works on a sorted sequence. Okay, we'll just say sorted sequence and we'll go with that. Binary search works by choosing a pivot, often the middle element. We'll put that in parens so that the commas don't get confusing. By choosing a pivot, partitioning the sequence at that pivot, hold on a second. Partitioning the sequence at that pivot and partitioning the sequence at that pivot. I'm getting there. No, you're right. That is what I'm thinking of. I knew it. I was like, what am I thinking of? I'm getting it confused with something else. It's because quicksort works. You're right. I am thinking of quicksort. It's hilarious. I guess we don't call it a pivot. Do we call it a pivot in binary search? Do people call it a pivot? I can't remember. No, I was thinking of quicksort because I literally just wrote out quicksort the other day for fun, because this is what I do on my weekends, is I write out quicksort. All right, let me just look real quick in this book. Just to see if they actually use the word pivot or not is really all I'm looking for. Okay. Binary search. Binary search, page 3. How about it? Nope, they don't use the word pivot. I just made it up. Nice. Great. Okay. Just kidding. Binary search works by splitting the sequence down the middle. I mean, technically you could split it somewhere else, but it would be kind of weird. I mean, yeah. I don't know if anybody actually would implement binary search that way. Binary search works by splitting the sequence down the middle. And it wouldn't be exactly log to it. Yeah, that's true. I actually don't like how I said this. Binary search works by okay, fine. Splitting the sequence down the middle, comparing the, we'll say the query to the middle element, or so. Comparing the query to the middle element, then recursively calling binary search, I should say partition, with the partition that contains, that could, that, okay, this isn't very clear. Binary search works by splitting the sequence down the middle. We'll say partitioning. Partitioning the sequence in the middle at the midpoint. How about that? How about that? Okay. At the midpoint. I don't know. Comparing the query to the middle element. Then recursively calling binary search with the partition that... Okay, well, let's just finish the sentence. That could, it's a bad sentence, contain the element, contain the query. Okay. The little sequence that could. There you go. What's up, Antonio? How's it going? Okay, binary search works by partitioning the sequence at the midpoint, comparing the query to the middle element, and recursively calling binary search with the partition that... I actually don't hate it now that I read it again. I mean, it's not very clear because there's not like a specific example. I don't hate the sentence as much as I did when I first wrote it. To the middle element and recursively calling binary search with the partition that could contain the query. Okay. Let's use an example in pseudocode to make it clearer. And recursing to the half that could contain the query. Okay. And recursing to... Ooh, by using the word half, I could make this shorter. By halving the sequence. Halving the sequence. Halving. I hate that word. To say it out loud anyway. It's very hard to say. You know, English is my first language, so it just makes it a lot harder. It's a BTC stream now. That's all we're talking about. Hey, at least my huge Bitcoin holdings are, you know, they're just going up. They're going up and up. I could be a thousandaire overnight. The little bit of Bitcoin that I never sold years and years ago. Sadly, I did not buy it when Bitcoin was very cheap. Gosh, that's the way it works. Okay. Binary search works by having the sequence, comparing the query to the middle element, and recursing to, buy high, sell low. That is actually my investment strategy. It works really well as long as you have a high paying job that makes up for all of your bad investments. All right. Recursing to the partition that could contain the query. Okay, yeah, we'll say half. And recursing to the half that could contain the query. Yeah, I think that's clear. Thanks, Antonio. It's good. An example in pseudocode. What is pseudocode? Basically JS. It's basically JS at this point. All right. Let A equals 1, 2, 3, 4, 5. Yeah, that is just a glorified gambler. That's fair. Okay. Python is pseudocode? Yeah, exactly. Let's see. An example in pseudocode. This is boring, isn't it? Should we do bigger numbers? I don't know. 1, 2, let's do Fibonacci. How about that? We could do Fibonacci. Well, it doesn't help us too much at this point. We'll skip 2 in the Fibonacci sequence. We'll pretend that's not a thing. 1, 3, 5, 8, 13. Yay, I can do math. 21. Okay. 1, 5, 8, 13, 21. Let mid equals I'll just say a dot length divided by 2, literally JavaScript, and we'll just pretend that this actually doesn't have, like, it's actually strongly typed, so this isn't going to produce a fraction, a float. Oh god, now I'm using closure syntax for comments. It's really, really, really good. Maybe I'll just do it without the a dot length. And so we'll just say midpoint is 3. Don't use slash for integer division. It's good. Sorry. You want me to use div instead? That's why I'm just going to hard code the midpoint. I could just use 4. Okay. Let query equals okay, so we'll just say query is 13. Okay. An example in pseudocode. I think I might actually leave it here. Like, maybe this is okay. Let's just try this. Let's see if I like this. Oh god, how do I get out of this fucking code block? Nope, escape didn't work. Like, no, that doesn't work either. Oh god. How does this work? Does their editor really not give me a chance to get out of the code block? No matter how many times? Maybe shift enter? Okay, shift enter. We're so good at this. I'm so good at writing. It's unbelievable. Okay. With this example, oh, okay, no, that's actually better. Since, oh god, how do I want to do this? I guess we'll do, you guys are gonna hate me. Maybe we'll do parens for tuples, tuple destructuring, and this is really clear, right? And we'll use things that people would only know in OCaml or Lisp, and we'll say a dot split 3. Okay. So that's pretty much it. That's pretty much what I did. Okay. With this example, yeah. Oh god. This is why I haven't written in a long time. It's because I used to be good at writing a long time ago. But now I don't know. I think I've gotten to like all over the place. it's too like not defined that I can just go anywhere with it, and I think that's bad for me. Okay, with his example, we would compare 13. We would compare our query. Okay, we'll just do 13. Okay, we'd compare 13 to 8. And since our query, okay, no, the query 13 to the middle element, close to the middle element. And since the query is larger than the middle, we'd recur down second. I'm going to change it to first and second. Okay. We would compare the query 13 to the middle element 8. Okay, I think this will probably look better like this. I guess we could also do this. We'll see how this looks at the end. We'll rename mid to middle. And since the query is larger than the middle, we'd recur down second. Okay. A really poor example in pseudocode. In pseudocode that no one's going to understand unless you know 5 different languages. All right. Okay. A dot split 3, first to second. We'd recur down the. Okay, how about this? We'd recur down the second half of the original sequence. All right. Okay, but really, like, how unclear is that? Like, you can be honest. On a scale of 1 to 10, how unclear was that example? I mean, obviously the next part is just writing code. I mean, I kind of assume that people have this isn't like I'm going to teach you everything about all of these things. Like, obviously, if you actually want to learn how this works, my little short blog post isn't going to help you a hell of a lot. But ideally, it's like you kind of know what these things are. I hope. Okay. Because we are splitting the number of elements, we'll say our search space, maybe. Our search space in half. At each step, binary search takes logarithmic time, aka O log n. Okay. Takes logarithmic time, aka O log n. Okay, I think that's fine. And then we're actually going to implement this on a slice. A basic binary search on a slice. Liam Plaz, 1, 2, 3, 4, 5. What's up? How's it going? Okay, so there's our to-dos. Wow, peaked. Sorry about that. Haven't done that in a while. Hurts my ears. Oh man, your cat's cute though. I'm guessing since it's missing an eye, it's a rescue. That's great. All your cats are. Good job. Good job. Oh dear. Are you... You would be in Grown Ups. Okay. If you could be in a movie, what movie would it be? I'll play this extremely off-topic game. Let's see. All right, chat. What movie would you be in if you could be in a movie? I'm guessing you mean like in that world? Or do you mean like just as an actor? Because that part I don't care about. If you mean in that world... I mean, the Star Trek universe isn't so bad. It's pretty cool. Hopefully you're not in the segments of the world that get randomly attacked by aliens. But in general, it doesn't happen too much. It's not a bad universe. It would probably be some sort of sci-fi thing. Whatever you want, yeah. I mean, like, there's the types of movies I like to watch, and then what I would actually like to do. I mean, the problem with most fantasy stuff is that it's in like a medieval setting, and there's not like good technology and stuff like that. And I don't really want to go back to those times personally. Time machine to chill with the Murlocs and Eloy. There you go. Okay, a basic binary search on a slice. We'll do that. I mean, it really wouldn't be much of a lift to just make this actual Rust, and maybe that would help people learn better. I can't decide. It's fine. It's fine. We'll just do it. We'll figure that out later. Maybe after I implement the binary search, then I'll care about that. A basic binary search on a slice. Okay, so then we just need to write a little conclusion. I think we might as well do it in Rust. Let me just rewrite this in Rust. It is in the title after all. Well, but the binary search is going to be in Rust, okay? The real code, I was trying to make it simple, but it's like that's basically Rust anyway. So there's not really a point in not just like the only thing that's not Rust is the fourth line, right? The rest of it is fine. So might as well just do it. Rewrite this in Rust, aka the fourth line. A basic binary search on a slice to do, sure. And yeah, okay. You may be wondering why we didn't implement binary search on an iterator. And let's see. Let's look at iterators thing real quick. Yeah. Dang, that's wild. I don't think I've ever seen that. I mean, I'm lucky if I get 960 downstream just in general. Like, I mean, that will happen on like fast.com sometimes if I have literally no other network congestion. But that's about it. This is the one that doesn't leak my IP, so I can actually use it. But like this is sadly my fiber going through coax over the LAN. Realistically, my Wi-Fi is probably faster right now. But I can't switch to Wi-Fi midstream, otherwise it kills the stream. You may be wondering why we didn't implement binary search on an iterator. Yeah, right. Yeah, there's a lot. You may be wondering why we didn't implement binary search on an iterator. And the main reason is that an iterator consumes you've hit over 1 gig on a straight speed test. Dang. But when you're actually downloading something, yeah. I've never seen 800. I've hit 960 on a straight speed test, but I only have like the 1 gig cap. I could get 2 gig here, I guess. I just haven't bothered paying for it. Mainly because since my office is on the other side of the fiber drop, I don't think I'm actually going to realize any greater speed than what I have. I mean, I guess it would help with network congestion. Oh, are you on? Did you get that on coax? If you only have 40 upload, you must be on 1 gig coax. Yeah, I have sequential since it's fiber, but yeah. Oh, wow. I'm very surprised that you got that on coax. That's impressive. No good fiber here, yeah. Well, we just got it. We're really lucky. We moved into this apartment like 3.5 years ago, and we had just coax, and it was whatever. You get like 600 on coax. That's pretty nice. And then AT&T ended up putting up fiber to our whole complex, which I was surprised about in some ways. I mean, it makes sense because it's a pretty large complex. Like there's a bunch of places here, so I imagine they'll make their money back. But then we're also getting public utility company fiber in a year and a half, so there will be at least some competition for fiber as well, which will be interesting. We'll have double fiber while the rest of the world has very little fiber. The rest of the country especially. But yeah, I was glad. I thought that we were going to have to wait for public utility fiber, but AT&T actually pulled through. And it's definitely been better than my coax experience. Well, I mean, specifically on the upload. I wonder what I'm getting on upload. I can't, if you click the more info on fast.com, it does leak your IP, which shows your actual upload. But of course, I'm also using upload right now. But usually I have a pretty good upload. Let's see what we're hitting. It's really bad right now because I'm streaming. Yeah, like 110. It's not bad during stream. I'm guessing the coax is kind of crapping out. I have a coax LAN in my apartment since I can't just run an Ethernet cable. It sometimes actually gives me full gigabit, but I think once it gets hot, it doesn't. Kind of sucks. Anyway, I kind of got distracted on that whole tangent. You may be wondering why we didn't implement binary search on an iterator, and the main reason is that an iterator consumes. Consumes itself, I think, is accurate. Consumes itself. Yeah, thanks, Nightshade. No. It might sound like I'm like blaming you guys, but I'm not. I mean, it's all good. On an iterator, the main reason that an iterator consumes itself. So we can't just compare to the middle element and then recur down the first half. We could recur down the second half if we wanted. But unless our element but this would mostly fail to actually find our query. Okay, I don't know if this is actually worth putting in here. You may be wondering why we didn't implement binary search on an iterator, and the main reason is that an iterator consumes itself, so we can't just compare to the middle element and then recur down the first half. Actually find our query unless we used another data structure to store the elements along the way, which defeats the whole point. Okay. If you weren't wondering, I'm sorry if you just read that whole paragraph. All right. There we go. I need a comma, not an X, a comma. There. I pressed escape because I thought I was in Vim. Okay. If you weren't wondering, I'm sorry if you just read that whole paragraph. Okay, so we might like walk through our code a little bit after we write it, but obviously I can't walk through the code that I haven't written yet. So this is conclusion. We looked at two ways. Okay, you have to reroute some cables. All right, I'll look at your packaging picture. Wow, they really cared. They really, really cared. Yeah, that's a pretty cool looking rig. It's very cool. And if you want to see Nightshade's rig and packaging, you can on our Discord. Okay. We looked at two ways of searching through a sequence. Linear search is more flexible. Works with any predicate, not just a comparison, not just a comparator, not just a comparison function. I could say comparator, but we'll just say comparison function. Works with any predicate, not just a comparison function, and doesn't require, maybe bullet points are nicer here. Doesn't require the sequence to be sorted. Doesn't require sorting. We'll just say that. Doesn't require sorting, but is slow. But takes linear time. Binary search requires sorting. Binary search only works with a comparison function of some sort. With a comparison function, requires sorting. Oh, fuck. Really? I'm sorry. I must have messed up this scene. Hold on. Is it just that I didn't... Oh. I guess it just turns out that this has always been a little bit off screen, and I just never knew, even when I was using Brave. Nice. Glad to find out today. Binary search only works with a comparison function, requires sorting. But takes in, but works, but is much faster on larger data sets. You keep trying to scroll. I do that so much. I hate that. You click something on the video. Like you're like, oh, maybe if I try refreshing this. I click refresh and it's like the browser refresh on the stream. Nice. This isn't working. Binary search only works with a comparison function, requires sorting, but is much faster on larger data sets. Okay. In the next post, I'll cover we'll talk about linked lists. And implement a singly linked list in Rust. Thanks for reading. All right, sick. Why does it hate this? Okay, binary search only works with a comparison function. Okay, only works with comparison functions. Requires sorting, but is much faster on... That's what it is. No, it still does it. Stupid Grammarly. Making me sign in, but I don't want to. But is much faster on larger data sets. Taking logarithmic time. Okay. Looks good. All right. So I think that's really nice. I think this post is for everyone. I don't actually want to publish it. No, don't publish. Why is there no back button? Why is there not an escape? Watch, it's not even like, it didn't even save everything. Oh, there's the back button. I swear it wasn't there a second ago. Okay, this looks good. I like this. And I think our post is done. All right, so next time we will actually implement linear search and binary search. I don't have time to do it today. But thanks for watching, YouTube, and we'll catch you later.